Hello everybody, in this lecture we will be solving 1991 IMO problem number 5. Here is a view of this problem. Triangle ABC and P an interior point inside this triangle. So let's go ahead and make a simple sketch. And at least one of the angles, PAB, this one, PBC, that, and PCA, at least one of these angles is less than or equal to 30 degrees. Show that. To begin with, let's call this angle, label it as alpha, this one as beta, and this one as gamma. We can simply assume that angle A, B, and C, they are all greater than or equal to 30 degrees. Otherwise, there's really nothing to prove. If the whole angle is less than 30 degrees, then obviously angle alpha would be, of course, less than 30 degrees. So that's why we can safely assume that. And now we can simply apply the law of sine on the following triangles, on triangle PAB, PBC, and PCA repeatedly. On triangle, let's apply it on triangle PAB first. For that one, we will get PA over, opposite PA is angle B minus beta, sine B minus beta is equal to PB over sine alpha. And when we apply it on triangle PBC, we get that PB over sine of opposite PB is C minus gamma. C minus gamma is equal to PC over sine beta. And finally, applying it on triangle PCA, one would get PC over sine PC is opposite, sine A minus alpha, and that's equal to PA over sine gamma. And now finally, we can just multiply these expressions, but before I do so, I will just bring the PB to this side and bring the sine B minus beta to the other side, and then multiply. So as a result, we would get the following. So we would get that multiply. So multiplying out, we get that PA over PB times PB over PC times PC over PA is simply, by the way, this is simply equal to PA's cancel, PB's cancel, PC. So this whole thing is equal to 1, by the way, but P over PB is just sine of B minus beta divided by sine alpha times sine of C minus gamma over sine of beta times sine of A minus alpha over sine of gamma. And we have, so this whole thing must be equal to 1, right? So we have just proven it. And in fact, this is nothing but the trigonometric, form of Ceva theorem. So in fact, we have proven the trigonometric form of Ceva, right? Consider the following functions. So we can split the left hand side as, consider f of theta, which is simply equal to sine theta, sine A, angle A minus theta, okay, sine angle A minus theta over sine theta. And in a similar way, and g of theta would be sine angle B minus theta over sine theta, And finally, h of theta is equal to sine c minus theta over sine theta. And we know that, well, the left-hand side here in our expression, and we know if we replace theta under f of theta by f of alpha times g of beta times h of gamma, that whole thing is equal to 1. We just proved it. We just proved ourselves the trigonometric form of Ceva actually. Okay, so that's equal to 1. But then, knowing that, well, each of these are positive, and I can apply, each of these terms are positive, and I can simply apply AMGM, to find an additive form by AMGM, f of alpha plus f of beta plus f of gamma all over 3 is greater than or equal to the cubic root of f of alpha, g of beta, h of gamma. But that whole thing is equal to 1. Moving things around, this would apply that f of alpha plus, oh shoot, okay, sorry for that, this one was g and this one is an h, g of beta plus h of, h of gamma is greater than or equal to 3. Okay, so we will make use of this in just a bit. So but what's important here is let's investigate a few things. So our function f, look at our 3 functions here: f of theta, g of theta, and h of theta. It's possible, so let's write that down. So consider f of theta, which is equal to that. If I apply the difference formulas, so sine a minus theta over sine, that's a theta, sine theta is simply equal to yeah, so we can just write it as, let me do it in 2 steps: sine a cosine theta minus cosine of a sine of theta, all divided by sine of theta, and then this thing is simply equal to, so f of theta as a result is equal to sine angle A. Cosine theta over sine of theta is just cotangent of theta minus, and the sine of thetas here cancel out, minus cosine of A. Now sine of A and cosine of A are constants. They are given in our triangle. Yeah, so between 0 and pi, we know that cotangent is a decreasing function, right? So everybody knows it has 2 vertical asymptotes at 0 and pi, and then it's decreasing in this range. So as a result, this whole function f is decreasing. In fact, we can, in a similar way, write down g of theta and h of theta by using similar expressions. So I will just skip that. So as a result, all f, g, and h are decreasing functions in 0 pi, in the interval 0 pi. Yeah, consider again the following. So consider we pick 2 angles x and y in the range 0 to pi, and then we have the following. So remember some trigonometric facts. Sine x plus sine y is simply equal to 2 times sine of x plus y over 2 times cosine. This is the sum to product formulas. Cosine of x minus y over 2, but then removing this will make the product larger. So 2 times sine x plus y over 2. So this is less than or equal to that. So in this formula, I will plug in two different pairs of numbers. So first, let's plug in x equals a minus 30 degrees and y equals b minus 30 degrees. Let's plug in these values into our formula. So that would imply that sine of a minus 30 plus sine of b minus 30 degrees is less than or equal to 2 times the sine of x plus y, a plus b minus 60 degrees, right? So that makes sense. And in a similar way, this time I would like to also plug in x equals c minus 30 degrees and y equals I can plug in 30 degrees. In that case, so this one here, sine of c minus 30 plus sine of 30 degrees is less than or equal to 2 times sine of the sum of these two, which is just c over 2. Now that's really nice. Finally, adding these two expressions, inequalities, side by side, on the left hand side, I would get sine a minus 30 plus sine b minus 30 plus sine of c minus 30 degrees plus sine 30 degrees is 1/2, right? Well, yeah, let's keep it on the left hand side for now. 1/2 is less than or equal to, so we have 2 times, let's just keep it like this. So 2 times sine of a plus b minus 60 all over 2 plus sine of c over 2. And now we can apply this rule again, this rule that we have just found. So this would be firm because we have the addition. So this would be further less than or equal to, remember the expression sine x plus y is less than or equal to 2 times. So there's already a 2 here. We will get another 2 sine of, and we would simply add the insides and divide by 2. Sine of, so everything divided by 2. When I add these two angles here, I would get a plus b plus c minus 60 degrees all over 2. So that over 2 we can put it here. A plus b plus c minus 60 degrees. But then things are really nice because well, a plus b plus c is 180 degrees, minus 60 is 120 degrees, divided by 4, 30 degrees. So this whole thing is 1/2. 1/2 and the 2 will cancel out, and then we can move the 1/2, this 1/2 to the other side, and as a result, okay, so let's write down carefully. Okay, so we have sine a minus 30, let's write down the final result. Sine b minus 30 plus sine of c minus 30. We have a 1/2 here, we have a 2 on the other side, is less than or equal to 3/2. And now finally, we make the following observation. So recall our functions f of theta, g of theta, and h of theta, right? So we earlier defined these functions here. Notice that f of 30 degrees, if I plug in theta 30 degrees here, we would get sine a minus 30 over sine 30. Sine 30 is 1/2, so flipping. So therefore, what we get here is, we know, we know that f of 30 degrees is simply equal to 2 times, because flipping the 1/2, 2 times sine a minus 30 degrees. In a similar way, we know that g of 30 degrees is equal to 2 times sine of b minus 30 degrees. And finally, h of 30 degrees is equal to 2 times sine of C minus 30 degrees. Now plugging these expressions into here, here, and here, this would imply that, combining it with this, we would get f of 30 degrees plus g of 30 degrees plus h of 30 degrees, and because well, each one would be f of 30 degrees over 2, g of 30 degrees over 2, h of 30 degrees over 2, multiplying out by 2, we would get this whole expression is less than or equal to 30 degrees. Finally, combining this result with, combining this with this one that we got earlier, right, that we, so let's call this the star expression. So combining star with, let's write down, this is 2 star. So we knew that f of alpha plus g of beta plus h of gamma is, oh shoot, okay, so this one was a 3 first of all. So sorry for that. Yeah, so this is greater than or equal to 3. Combining these two results, then this implies that either so either f of alpha is greater than or equal to f of 30, or g of beta is greater than or equal to g of 30 degrees, or h of gamma is greater than or equal to h of 30 degrees, right? So and since our functions, so our function f, g, and h, all of them are decreasing functions, what it implies is if the first case holds, so one of the cases have to hold, right? Because there's no way that these 3 will add up to something less than 3 and these 3 would add up to something more than 3. At least one of these 3 is achieved, right? So one of these 3 cases, case 1, case 2, or case 3 is the case. But if the first case is what happens, then because our function is a decreasing function, it must be that alpha is less than or equal to 30 degrees. If the second case is the case, then beta, it means beta is less than or equal to 30 degrees, or gamma is less than or equal to 30 degrees. And this is exactly what the question was asking for, showing that at least one of these angles, one of either angle PAB or angle PBC or angle PCA is less than 30 degrees. So this was a significantly computational proof. I would, if time permits, I would like to show a non-computational proof as well. But hope to see you guys. I hope you enjoyed it, and hope to see you guys in our next video.